Hey everybody, this is the Pendulum lab. So it's going to be the most time consuming of the semester, so we're going to split it up into sections. So if you take a look at this kind of generic pendulum setup here, there's some mass M over here, that pendulum bob, some string of length L, and then it's going to swing, and then there's some amplitude, which we can just quantify as an angle, theta. And then it's going to take some period of time to kind of swing and then come back. So that period of time, we'll just call some letter T, T for time, so period T. And then again, there was some amplitude theta, I'll just call it some angle theta, mass M, length L. So the purpose of this lab is to find the function. What is period T as a function of the angle? What's the period as a function of the mass? What's the period as a function of the length? And then fourth, let's solve for the acceleration of gravity. Use the pendulum to measure it. So I'm going to measure the acceleration of gravity. Okay, and then let's split it up. Let's do these two in this video, and then these two in the next video. Okay, so first let's talk about how to set up the apparatus. So I'll leave it to your creative style and critical thinking skills to set up your pendulum. So I'll just walk you through how I did it. And maybe a disclaimer, I made decisions based on how it'll show up on a video. So you wouldn't necessarily need to make these considerations. So for example, for the kind of the hinge portion of the pendulum, see, I just taped two pencils together. And then I looped the string around one of them here, because my thinking was to adjust the length of the string. I could either, let's say, tape some mass to the end of the string and then just keep moving where it's taped along the string. So, right, like if I tape it over here, then the string is only this long, but then if I tape it here and tape it here, so where I tape the mass on the string adjusts the length of the string. Or I thought if I do this, then I can just wrap the string around the pencils. So the more I wrap it around the pencils, the shorter the string gets. So that way I can adjust the length of the string by just wrapping it around. So that's what I did. You can do whatever you think of. So and then I just taped it to the top of a door. And then make note that I purposely taped it where the pencils are horizontal, because if the pencils were, let's say, like this, and then the string were like over here, then when the string swings toward the left, then it's maybe like this. But then when it swings toward the right, it'll look more like it'll kind of wrap around and go this way. Like this. So that's not good, because you see, when it swings toward the left, it's like it's pivoting over here. But when it swings toward the right, it's pivoting over here. So it's like the length of the string will change by this much. It's small, but just something as simple as turning the pencils horizontally like this, then when the string swings toward the left or swings toward the right, then it's a negligible change in the length. So I went with that. And then why did I tape it to the top of a door? It would have been so much simpler just on a table. And then let's say just the pencils are like right here. And then I just either put tape or put something heavy to weigh the pencils down. And then it's swinging like this. That would have been much easier. But then it's kind of hard to see on camera when I video. I needed some kind of background, so that's why I did it up against the door like this. And there was about maybe an inch of space between the string and the door. And then I had to be careful that the mass doesn't scrape against the door, because then that would introduce friction. That would be bad. And then at the top of the door, because out of frame right over here, I have a bright ceiling light. So I needed that bright light for the video. So all these decisions are just for the video. And then even the string, like I think it would have been better to go with something like dental floss, because one, dental floss, like it doesn't stretch very much, so that's good. And then it's low in mass, and it's really thin, so it doesn't introduce too much air drag. But then it's kind of hard to see on video, so I picked this kind of black colored yarn against the white door, so the contrast is easier to see. But then yarn stretches a little bit, so that's not good. And then it's thicker and kind of fuzzy, so introduce more air resistance. Also not good, but that was the trade-off for video recording decisions. Okay, and then to adjust the mass, I just taped 2 nickels. So you see how I just pinched the end of the string between 2 nickels and then just put tape. So that's my mass. And then I picked nickels because I had a bunch of them lying around, and I know that 1 nickel is 5 grams. So right, if I have 2 nickels, that's 10 grams. Then if I tape 2 more, 4 nickels, 20 grams. I tape 2 more of those. If I have 6 nickels, then that's 30 grams, right? So then I just kept adding pairs of nickels to adjust the mass by 10 grams each. And then I tend to prefer using like masking tape, like this blue painter's tape. But then I just use Scotch tape over here just so that you can see on the video that it's nickels. So again, more filmmaking decisions. Okay, and then to measure, let's see what is left. Angle, I taped a protractor up here. That's the same one I used in the vectors lab in the beginning of the semester. And instead of my clear transparent plastic protractor that doesn't show up well on pictures or videos, I just searched for an image of a protractor online and then printed it and then cut it out and just taped it to the door. But you could also, just to show options, I took my tape measure and then another ruler like this, and I just taped it to the door. So like you see this triangle here, you could just measure the angle directly with the protractor and then you're done there, right? But if you know the length of the string and you know what angle you're shooting for, then let's call this some distance x. Then just trigonometry, right? Sine theta is opposite over hypotenuse. So then you could, let's say you don't have a protractor, you could just measure the length of the string, and then if you want 10 degrees for something, right? Then say x is L sine theta. So then you can just use a ruler like this and then trigonometry to get the angle that you want. Okay, now for measuring period, you could just video record your experiment. 3, 2, 1, go. And then you just take that recording and then just count the number of frames. And then you got it. Then that's the period. Or another option is you could say, let the pendulum go and swing maybe 3 periods. Say 1, 2, 3, and then use a stopwatch to measure. So for example, like this. So ready, get your stopwatch ready. You're like, ready, set, start. 1, 2, 3. And then you stop the stopwatch, make note of that time, and then just divide by 3. So then that would be 1 trial. Okay, and then let's get back to our whiteboard. So let's say you want to measure the angle. So you should measure 5 different angles, 5 trials each. But we want to stay below 10 degrees because here's our hypothesis. I'll just write it over here. Our hypothesis is the period is like this. Okay, so you can just save this for small angles. And I'll explain this in another video. So the period is a function of the length and g, but notice what's missing. It's not a function of the mass or the angle. So the mass shouldn't even affect the period. The angle shouldn't affect the period. Only the length and g. So if you do this on a different planet, the period will be different. But this is for small angles. So let's decide on what small means. Let's keep it less than 10 degrees. So if you do 5 angles, 5 trials each, I'll just make it like a table. So let's say you go 2, 4, 6, 8, 10. Right, so that's 5 different angles. And then we're trying to, let's say, less than or equal to 10. And then 5 trials each. So let's say trial 1, 2, 3, 4, 5. And then we want multiple trials because you want to take the mean and then the standard deviation. So for example, you say, okay, 2 degrees. You let it swing 3 times, measure it on the stopwatch, divide by 3. That's trial 1 for 2 degrees. Then you reset and make sure you use the same length and the same mass because you should only adjust one variable at a time, right? Okay, so now trial 2, 2 degrees, let it go, let it swing 3 times, stop, divide by 3, write that down, okay, and then reset, 2 degrees, let it go, swing 3 times, divide by 3, there you go, and then you do 5 trials, and then take the mean of these 5 over here, right, and then next angle, 4 degrees, and then you do 1, 2, 3, 4, 5 different trials, then you take the mean, right, and then you do all 5 different angles, and then you're going to make a graph of period as a function of angle, right? And then you had 2, 4, 6, 8, 10. Okay, so let me show you a clip of what I recorded. This is for 2, 4, 6, 8, 10 degrees so here, 2 foot length of string, 10 grams mass, 2 nickels. I just let it swing 3 periods for this particular video. So ready, go. 1, 2, 3. So that's 2 degrees. Now this is 4 degrees. Okay, this is 6 degrees. 8 degrees. And 10 degrees. Okay, so let me show you kind of a composite. So here I split the screen into 4 quadrants, and then I have 2, 4, 6, 8 in the upper left, upper right, lower left, lower right. And then I have them all same length, same mass, but then different angles. And then I recorded this, and then this is at half speed. So just make some qualitative observations here. So I'm going to let this play. Ready, go. Okay, so that was 4 different angles. What did you notice qualitatively? Right? So it seemed like it's the same period no matter what angle, qualitatively, just based on our observation. And if you look at the hypothesis here, yeah, we're expecting the period to not be a function of the angle. Our observation kind of supported that. So now that it's up to you to quantify it with data here. So you collect data, graph it, right? So here, if you have the period, so each of these data points on your graph comes from the mean of your trials. And then you do a trend line like this. And then you look at the equation of the trend line. We're hypothesizing that the slope will be close to 0. Right? Because if it's horizontal, that means the period is not a function of the angle. So this is what, right? So do this part this week. Take your data for 5 different angles, 5 trials each. Make this graph and see if the trend line is indeed horizontal. Okay, and now let's talk about the mass. So let's adjust the mass, and then that'll be it for this week. We'll do the length next week. Okay, so for mass, I'm just going to recycle this table. So I did nickels, right? So I did 2 nickels, that would be 10 grams. And then I did 4 nickels, 6, 8, 10 nickels. And I mean, you can use whatever you have around the house. Okay, so then I'll just show a clip here. So this is just a composite of 3 swings each for 5 different masses. Okay, so this is 10 grams. Ready, go. This is 20 grams, 4 nickels. It's 30 grams, 40 grams, and 50 grams, 10 nickels. Okay, so now similarly, I just split up my screen into quadrants, and then I have here 20, 30, 40, 50 grams. And then same length, same amplitude. Let me start them. Ready, go. Okay, so what is your qualitative observation here? It appears as if it's the same period for all of the 4 different masses. Right, so that's our qualitative observation. And then again, if our hypothesis here, right, the period shouldn't depend on the mass. So now it's up to you to quantify that with data. Right, so again, you set up, for example, your first mass, say like 10 grams, let it swing 3 times, divide by 3, there's trial 1. Okay, reset it, let it go, let's say swing 3 times, divide by 3, there's trial 2, right? And then you do 5 trials, take the mean. And then, right, do all 5 different masses. And it's fine if it's not like even multiples, as long as it's different values. Like it doesn't have to be perfect like this. Okay, and then you just graph period as a function of mass, and then you'll have your 5 different masses. Each of these data points, again, is the mean of your trials. And then you do a trend line, look at the slope of the trend line, and we're expecting it to be pretty close to 0, meaning horizontal. Okay, so it's a lot of work, so that's why this is just one whole week's worth. And then next time, we'll talk about adjusting the length. So that in itself is going to be time consuming, and you need more data points. Okay, so start off setting up your apparatus, and then, take a bunch of pictures to document your work, and then get started collecting your data and then making these 2 graphs. Let me know if you have any questions. Just post it to the forum, then I'll see you on the next video.